Today, we explain the use of the switch tester video teaching. First, let's determine whether the switch tester is normal or not. Plug it in first, then power on. First, we check if the fracture is working properly. We can find a short cable. Then plug one end into GND1, then the other end is in hand. We will then hit the instrument to the settings menu, status detection at the bottom, then enter the state detection. We can see that all the fractures are completely compartmentalized. This shows that it is a preliminary judgment. This fracture is fine. Then we put the corresponding fracture. For example, the A1 fracture. We plug in to short the ground. Then it becomes combined. I pull it out and it becomes a split. This shows that A1 is normal. B1 is also inserted and combined. Pull it out to divide. C is also through this fracture state. You can judge whether the fracture status is normal. Then the public end at the upper end. The public side is GND1, A3, B3, C3, A4, B4, C4. The common end is the integral GND2, our corresponding insertion. You see, A3 has changed, bringing up A3 variation again. By this method, we can determine whether the fracture is normal. Then we can determine whether the sensor is working properly. We plug the rotary sensor into the rotary window. One end of the signal cable is inserted into the sensor. One end is inserted into the instrument interface. Then we choose to turn the sensor slowly. The arrow above the sensor, the arrow on the liquid crystal of the instrument is also moving slowly. It means that the sensor is working normally. If it jumps or fluctuates a lot, that means there may be a problem with the sensor. Now, this way judges that there is no problem with the fracture. There is no problem with the sensor signal. And then we make the most important judgment. Is there any output voltage? We short the fracture cable. This internally triggered power short cable. We connect, then choose a multimeter. Turn the multimeter to DC gear. Then we put the red and black stylus of the multimeter. Connect to this internally triggered red and black short cable. Then we choose to test the manual split below. Opt in. I clicked wrong and selected manual separation and combination. Opt in. The current screen voltage is 220 volts. The LCD indicator is also 220. And then we looked at the multimeter. Then we prompt that there is a left button closing output on it. Hold down the left button. The closing light is on. Then the multimeter indicates 220 volts. It means that there is no problem with the closing channel. Release the hand. Closing channel. No voltage. The description is normal. Then the other channel is the communication channel. The other channel is the opening channel. Let's test the opening channel. Press the right button to open the gate. Opening indication to 120.1. Release the hand and turn off the indicator light. Then the multimeter doesn't read. Description, no output. This also means that this is triggered internally. The DC power supply in the instrument is working normally. Past the above three judgments. One is fracture signal detection. One is sensor signal detection. There is also an internal trigger DC power supply detection. We can preliminarily determine that the instrument is working properly. As for energy storage, the same method can be used to judge. Lock-release power supply. It is inserted through the horizontal plug cable of the two cores. Then the multimeter hits the DC gear. Display, as long as this place shows it has voltage. That means it's normal. So that's it. Now let's talk about the switch tester. All the accessories of the accessory box and their operation. First, we open and hold down the button with both hands. Then open the spare box. What you see is a set of test lines. Power cord, universal bracket, printing paper, closing and opening control maintenance accessories, 50mm linear sensor, and its accessories, rotation sensor, accessories for VSE switches, speed measurement accessories for vacuum switches, magnet accessories composed of 3 strong magnets, accessories for rotation sensors, accessories for vacuum switches. Let's take a look at our test line. First of all, this is the signal line of the sensor. Fracture short cable. And there's the internal trigger wire. External trigger line, grounding clip. There are also transition columns and small control clips, then the yellow split gate line. Green. Red fracture extension cord. Fracture line for vacuum switch. Can also be used as an extension cable for the fracture. Just these accessories. Let's go through them one by one. This screw has 5 screws. This is for a rotation sensor. Single screw positioning hole. We can plug it in with the jack. Then lock it with the matching in a hexagon. This head is connected to the sensor. It is fixed with the body of the switch, and we hold it in place with a universal bracket. As the switch turns, the axis of my transducer is moving. The sensor body does not move, so you can measure its travel speed. These 5 choose the appropriate one according to the situation on site. This is a rotation sensor. If the rotation sensor is said to have 2 fixed holes, we choose this bracket. The first is to fix the bracket. Positioning hole with field switch. These are 2 opposing positioning holes. See which one is suitable, then hold it in place. Then the rotation sensor is fixed to it. Then lock the handle of the rotation sensor tightly. This turns the switch and drives the sensor to turn. The speed can be measured. This is the second bracket for the rotation sensor. The third bracket, it's a magneto-magnetic support for the rotary transducer. If you encounter the on-site switch, there is no positioning hole. Not a single positioning hole. There are no 2 positioning holes in this way either. We use strong magnetism. We are a strong magnet composed of 3 strong magnetic materials. We suck the switch through the screw. Loosen this screwdriver. This sleeve can be removed. Then the axis of the sensor is fixed to this. That's it. Then connect together. Carry out the corresponding transmission. Speed measurement is also possible. This is the third accessory for the third rotation sensor. And then there's the linear sensor. Linear sensors are mainly used for vacuum switches. We have several major accessories. The first one, this is a universal knot. Prevent twisting and twisting of the sensor. We can combine it with this little magnetic together. If there are no screws, you can use this magnetism to attract it and move it together. Fix it with a universal bracket. Then the sensor moves up and down. Run a test run. Speed measurement. The second one, if there is a screw positioning hole, and we're going to use this device to connect to it live. Then this end is threaded to the movable reservoir head of the switch. In this way, the moving reservoir head of the switch drives the sensor to move. Travel speed can be measured. These 2 are matched, a big one and a small one. Then there is another one. If it is a clamp, the movable storage head comes out with a certain height. We can use this clamp, then card it on. After screwing it on, this clamp screw can be pushed out. Screw is movable storage head together in the future. Then moving the reservoir will drive the sensor slider to move. Travel speed can be measured. This is dedicated. Stroke testing 4 versus 1 switches can be installed on the side of the versus 1 switch. Then the rotation sensor is fixed. It can be tested by fixing it on the side. It uses a sliding sleeve of the sensor. This rod is connected to this axis. Then it is connected to the sensor. Or this rod of this versus 1, connected directly to the rotation sensor. Then lock it with screws. In the sensor, the white hole on the side of the versus 1 switch. Insert, so it rotates with the switch. The sensor measures the speed. This is specifically for VSE testing. Accessories for sensors. And its use. So that's it. Let's explain how to use the switch tester. Well, we switch on and off with a vacuum. VSE vacuum switch as an example to explain. So let's start with this. We're going to connect the fracture wire of the switch tester. Then the energy storage cable is connected. Connect the sensor wire and the inner touch valve. First we plug it in. Plug in the power cable. Then connect the ground wire. Because we are in the laboratory, we're not grounded. This doesn't make much difference. Then we connect the fracture wire. The fracture of the switch is divided into the upper fracture and the lower fracture. We connect the upper fracture to a 1B1C1, yellow, green, red lower fracture, short grounding. If there is a switch encountered on site, he has this CT with a current transformer. We put the end close to the current transformer to short ground. Cannot connect to the secondary side of the interchanger. After the switch comes out, for example, the switch here exports to the transformer, then connect it to the exit of the switch, instead of connecting to the transformer. This is the point to pay attention to at the scene. If connected to the later stage of the interchanger, there may be errors in the measurement. This is the point to be aware of. Then we connect the fracture line. We can now connect the already connected fracture line. Insert into the instrument. Short, the wire, and then yellow, green, and red corresponds to ABC. We connected the fracture line, and then now we have put HTC's line of control. It's coming out of the terminal. We made a terminal. And this is one of the terminals we made. Then this is the energy storage line for closing and opening. Then the sensor. This is the control line of the closing and opening gate. We have two now. One is the rotary transducer. This is a dedicated rotation sensor for VSE. And then this is a magnetic watch post. A watch column. It's a universal bracket rotation sensor. The sensor indicates between these two layers. And then there's another sensor. They use linear sensors. 50mm linear sensor. This is the bracket. This sensor gives its dynamic storage head. Fix it together and we can measure the itinerary. This linear sensor can measure travel. Rotation sensor. It can only measure the speed, the range, the parameters. We now connect the wires in sequence. This is the energy storage interface. Red is positive. Black means negative. Because of this power supply. Energy storage power supply. Internal trigger power supply and lock interpretation power supply. It's all the same power supply. So positive and negative must not be reversed. Then the internal trigger is connected according to the color. Can't be wrong. Okay, the internal trigger is connected. Now let's put the sensor again. Connect the linear sensor. All the wires are now connected. We turn on the power. Set up the instrument. Because of the switch of our VSE, it does not lock and release the power supply. If there is a VSE switch on site, it has a latch. Then use our short cable to let it out. Two wires let out. After receiving its lock, positive or negative, the lock can be lifted. So we start with a contrast adjustment. These two keys are contrast adjustment. Then press OK, or press the return key, or press the right button, or press the left button. The main menu can come out. Then we move to the settings interface. Now the main cursor. First press OK. Enter test settings. We first trigger the way. Internal trigger, external trigger, sensor trigger, and manual trigger. We choose internal trigger. Then test duration. Generally, our instrument. Usually the longest is 64 seconds. Can satisfy outdoor. High voltage isolation switch. It's concurrent time and concurrent testing. We usually choose 250 milliseconds, which is enough. Then the sensor defaults to item A. What we do now is a linear sensor. We choose linear sensors. Then the type of sensor has linear rotation. With electric shock sensor, there is also a rotation sensor. There are also acceleration sensors. This accelerometer and electric shock sensor are optional. The electric shock sensor is mainly a vacuum switch. Then the accelerometer, mainly for outdoor use, 35 kilovolts, 110,000, 22,500 of this kind. Switches with outdoor linear structure use more. What we're demonstrating here is a linear transducer. If we're going to start this itinerary test, we want to measure the travel of the switch. Then the input for this itinerary is standard travel of the sensor. Our standard travel for this sensor is 50. Let's say we shut down the itinerary test. Then this place is entered. That's the total travel of the switch. For example, the total travel of switching stroke of this versus 1 is about 12. Then lose 12. Or this switch is 12. Then we lose 12. Now let's test the itinerary. Okay, then we choose to turn on. Then the travel setting is the travel of the sensor. Then the speed is defined. We choose this switch to close the front seal and the back 6 millimeters, because we have a lot of speed definitions solidified here. If not, we can use data analytics. The line number can be edited at will. 26 letters. Numbers can be edited at will. This is fine. Then the closing factor, opening coefficient. This is a commonly used switch. Usually the default is 1. And we're going to set the voltage again. 220 volt DC switch structure. If this is 220 volts, there are prompts under the LCD. Up and down keys, left and right keys, course adjustment, up and down keys, fine tuning. Press the back key to exit. We press OK to save the voltage. Then it can be tested. When a 1B1C1 is broken, we can choose the automated test mode. We will choose the rest. You can judge for yourself whether it is divided or combined. We now choose the automated test mode. Everything you just set up is on the screen. The state of the switch is also correct. Now it's sub-state. The voltmeter indicates 219 volts. 1 volt away from our screen. It doesn't matter. This is 1 volt and 2 volts, and it's fine. It does not affect the operation time of the switch. Simultaneously, these parameters. We're going to press OK. The switch will act. Why is there no action? Maybe we don't have stored energy, because our line has no contact. We'll store his energy. First, we can store the energy for him. Press the OK button in the energy storage control to output energy. Voltage, storage, and timing. OK, choose to press the OK key to stop the output. Then press the back key to exit. In the energy storage interface, we can also choose to let it automatically store energy. The switch is acting. It will automatically store energy. We can set the energy storage time to 15 seconds. We do it now. Automatic test of the switch. Press OK. The switch will close. It's on. Data coming soon. The data appearing this time is 45.0, 44.7, 45.5. The same period is 0.8 milliseconds. Bounce 0.8 milliseconds. 0 milliseconds, 0.8 milliseconds. Speed 0.56, 0.58, 0.52 meters per second. Maximum speed 0.88. Resistance 131.1 ohms. Explain that this is the resistance of the closing coil. Coil current 1.68 amps. If we want to choose to save, just move it to the file. Just save the file. We choose to print. Comprehensive printing. It's all printed out. Page printing saves paper. You can choose to print the current data. If we have other parameters, we can put it in the parameter options. Open this other parameter. Look at this, overcharging these data. We can choose to turn it on. These are of great significance to vacuum switches. Okay, when we look at the data, he will have how much is the override? What is the total itinerary? Total itinerary 10.6. How many over trips will there be? You don't need to print this. Okay, let's do the opening test again. We can still choose to automate the test. Open test can also be selected. We choose the open test. If the state is closed, you can do the opening. Press the OK key to switch the action on and off. After the action is over, switch automatic energy storage. We've just set it to automatic energy storage. It will automatically store energy. Because this energy storage power supply is 30 amps, but we are mainly used for energy storage requirements of vacuum switches. Because the motor loses a lot of current when storing energy, he may have reached the rated value, more than 10 times the rated current. This kind of institutional energy storage, he's probably afraid of ruining the power supply. We are mainly used for 35 kV and below. The energy storage of this vacuum circuit breaker. Then our opening speed measurement data came out. Open distance of item at 10.2, 9.8, 9.9. A, B, C, all three speeds. There are 3 open distances. Maximum speed rebound. This coil current, coil resistance is available. We can see the graphics by pressing the button. You can also print this. You can also press save. If there is no definition of speed in this, meet our requirements. We can choose data analytics. We can move the cursor to switch. The up and down keys are to switch. The cursor becomes a solid line and can be moved. The left and right keys are to move. The up and down keys are to switch. The current data. These time values. Delta S delta T changes. Then its delta V will also change. If you want to be sure, press the OK button to reach it. It's very simple. It is also a very useful function called data analytics. Regarding the DDR test, We've got that stored up now. We can also give him a DDR test when doing a DDR test, but we need to know when to switch it on and off. The current state of the switch. We close the low jump. There are several ways to low jump. One is manual separation and combination. I adjust, for example, I just watch him at 214 volts. See if he can close it. Okay, I press the right button. Press the right button to close the closing switch. I can record it at this time. So this is low voltage mode. Another way is, for example, we now choose fully automatic low jump. We do it because the switch is already closed. We do the opening low jump. We set the pulse width to 250. This 260 does not need to be changed. Stepping 3 volts is also okay. We can set other voltages higher. For example, set it to 24 volts, and then we select OK. He starts to automatically increase the pressure. When does the action machine stop? Because of this requirement, auto low hop, there must be a fracture line. If there is no fracture line, he can't detect whether the switch is separated or not closed. So he had to have a fracture line. Switch action. The switch is already closed. The switch has been separated, so it regulates and ends the action. Voltage 78 volts. The voltage will drop to 0. It's coming down. Then you have to choose to print. Press back to select print. You press OK. He will print the low jump voltage. This is also a fully automated low jump. Fully automatic low jump needs to know this. The fracture line must be connected. First of all, now that we're apart, we will use energy storage in the future, because only when doing this single division, single combination, it will automatically store energy. When we do this low jump, he can't store energy. We're going into energy storage at this time, because when the voltage drops, we tune it up. We adjust the voltage to 220 volts. Then you can power up. Store energy for this motor. That's about it. Give him energy storage. End, exit, return. Let's do another one now. Manual low jump test. This low jump test manually. The difference between manual low jump testing and automatic low jump testing, it's a manual low jump, is to determine whether he is united or divided, but you can do without the fracture line. I can now unplug the fracture wire. All you need is an internally triggered control wire. Just go to the coil. Now, because of the state of the switch, we can also see that it is dissected already. The status of the switch has been separated. We are now doing a closing low jump. We choose manual low jump. We choose to close low trip. And then this time we click. Output the control pulse of closing and opening. The voltage can also be adjusted at this time. Let's say I turn up the voltage a little bit. Now, 27 volts. I click it and it will output. He is by step. We pressed 3 volts just now. He presses 3 volts to go up. Our 98 volt switch action. This time, we can end. This low voltage operation was tested. External trigger is to use the DC power supply on site to control my on-off action. For example, I set it to trigger externally. After external trigger, the instrument will not have a signal. The instrument has been waiting. Only external voltage signals are coming in. The switch will act. The data will be recorded. There is also manual triggering. For example, our VSE switch. You can also do manual triggering. Just plug in the brake wire. No control line required. We choose to trigger manual. or the sensor can trigger it. We choose to trigger manually. Now it's time to divide. I split the switch for the past and the present. Push the switch off. At this time, because too much of me is artificially timed, so it has no accuracy. It was right at the same time. It's the time clock starting point, because I gave it artificially, so it's not very accurate. We can choose. If you want to be accurate, we can choose sensor trigger. Time to trigger it manually. This way. Bounce, these are all right. This can't be wrong. And then, we can choose sensor trigger at this time. We can look at the sensor triggering. Sensor trigger means that the sensor has moved. He started the clock. Because we may not have the energy right now, we add energy to him. Store him energy. Let him unplug the energy storage. The voltage is low. Storage voltage is low. I am afraid that the voltage will not be stored. We raise the voltage. Raise to 220. Stored? Let's do it again. Don't reset after this energy storage is over. Follow his operation process. If you reset directly, this may not be turned off. This is not good. It is easy to damage the node of the relay to him. Determine to stop output, then press return to exit. At this time, we will choose the sensor trigger again. The settings are normal. And then we test it. The sensor is moving. He started taking notes. Because we're not connected to the fracture line either. It is also not connected to the control cable of this closing and opening gate. We are also human. To give him a signal, the switch is divided. We're going to close this now. It's on. We have all the data. The curves are all there. Basically, what we tested just now is, it should be the same. Let's look at closing. Check the time. 0.57, 0.56 is speed. 0.56, 0.57, 0.59, 0.58, 0.52. Time, 45. Slight time difference. Because of the timing of the sensor, it must be a little different from closing and opening. This is mainly used on site, when it is not easy to connect the opening wire. It is also possible to use this trigger method. Use this internal trigger or external trigger. It collects. There is a starting point for timing. It's a little bit more accurate. It's the signal. This is the way to time. The starting point. This one is a little worse, but it should also be able to meet actual needs. This switch tester. Watch this on the spot. So much for that.